Welcome to the GOTO Podcast. In this episode, Matt Turner, SRE at Wace, speaks with Brandon Burns, co-founder of Kubernetes and co-author of Kubernetes Up and Running, dive into the future of infrastructure. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hey everyone, my name is Matt Turner. I'm an SRE at Wace here in London. I've been working with Kubernetes for quite a while. I feel like I know a fair amount about it, but with me today is Brandon Burns, co-founder of Kubernetes and co-author of Kubernetes Up and Running, dive into the future of infrastructure. So Brandon, welcome. It's a pleasure to meet you.
Thanks. It's really great to be here and have a chance to chat.
So I think I'll dive straight in with my first question, which is kind of going to ask you to introduce yourself anyway. I was wondering if you could tell us briefly what your role is now. I feel like I understand what a normal vice president does, but you're a super technical guy. So what are you up to day to day?
Sure. I'm generally responsible for cloud native open source on Azure, Microsoft's cloud, as well as sort of all of the APIs that drive accessing the cloud. So my teams are responsible for sort of the metadata layer that you interact with when you interact with Azure. Doesn't mean necessarily that we go and provision the VMs, but we deal with the templates and policy and access control. So generally, I think cloud native and DevOps for Azure. But as you say, I sort of can't help myself from coding as well. So in addition to sort of running a fairly large set of teams, I'm also doing things like maintaining the clients for Kubernetes. So I maintain the JavaScript and C#, and actually these days C as well. There's a nascent C client for Kubernetes being developed. It's a good reminder of how painful it is to program in C.
I bet. Yeah, but it's a nice difference from all the big company meetings that you might have to go to.
Yeah, for sure. It's definitely it's nice to have a little, and I learned that sort of over time that like, as you have other responsibilities, it's important to pull yourself out of kind of the main line, but find those areas where you can have an impact and where you can contribute. Where if I have to go away for a week and I have to go deal with a customer or go do a bunch of meetings, like nobody's going to really care if the Java client is delayed a little bit, as opposed to being in the main line reviewing PRs and stuff like that. Like you're introducing a lot of latency for other people.
Sure. So I was going to ask, how closely do you follow upstream Kubernetes? It sounds like you're not sort of hands-on as a maintainer, but how involved are you with the sort of original project these days?
Yeah, I think I'm involved with it in the sense that, a lot of what we do is helping deliver success for our customers using Kubernetes. And so I'm pretty involved with it in terms of understanding, how it's evolving release to release, what's going to break release to release, what's gotten better release to release, and trying to anticipate potential problems at scale, right? We have thousands and thousands of customers, and it's a little bit different. You see something and you're like, probably most people won't hit that. And that's true. But once you have tens of thousands of customers, that probably becomes a certainly, right? And so trying to sort of think about that and usability as well, right? There's been a really interesting discussion around, things like, should we add confirmation of delete to kube control, right? Which is kind of, first of all, it's kind of an interesting question that it's 7 years in and we're only just starting to have that conversation. But it also is really interesting to see all of the different perspectives come out of the woodwork from people who are like the people who have all the scars from accidentally deleting stuff. But then also the people who are writing automation in scripts and stuff like that, and who are like, I don't want to add --yes to every single line in every single script that I've ever written. And then sort of from my perspective, one of the things I think about is like, actually, I feel like this should be a cluster administration capability where I can actually say, hey, these are the things that I care about. And regardless of whether you put --yes or not, you're locked. Like you need to make an explicit gesture, like removing an annotation or, something like that to delete something, because I think one of the other things I do a lot of actually these days is I do a lot of the sort of cross Azure live site reviews, postmortems and things like that. And when you do that, you get this breadth of perspective about like how accidents happen. It's kind of like, I have a friend who's a vocational counselor who helps people rehabilitate after like job site interview or injuries. And like his perspective of how dangerous it is to work in particular industries is a little bit skewed by the fact that like he sees all of the bad stuff that happens, right? And so it's sort of similar when you go through a lot of postmortem reviews. You start saying like, oh, okay, actually, like we need to put some safety guards in here that you as a user may not love, but like will prevent you from hurting yourself. I don't know. I was sort of moving along dotted directions there.
Yeah, no, that's really interesting. I mean, I was a software engineer first and kind of moved into the infrastructure stuff. And I remember, very, very quickly got that attitude of what are the devs doing? This is crazy dangerous. Like stop. But I also remember when delete became synchronous, right? It doesn't ask for confirmation, but it used to be instant. And then all of a sudden it took a while. And we were all like, what is this? What is this bug? What is this bug? I just wanted to go fast. I just want to tell the cluster to, make a best effort. So I guess I still had some of that, sort of dev in me. And yeah, it's interesting, especially in a smaller company, how you wear all those different hats. And it sounds like you interact with people who wear all those different hats and you have to try to make all of them happy.
Yeah. Yeah. I mean, and we have, it's really fascinating. I mean, we've been thinking about, how do you create policy to reduce manual touches, right? It's great to aspire and tell people to reduce manual touches. But actually I find that like aspirations are no substitute for actually like implementing policy. But then like, there's always somebody who has some workflow that you're going to break. And how do you negotiate them along and help them through maybe changing their workflow, changing the way that they, or understanding, like maybe understanding where they're coming from.
Yeah, no, absolutely. Are there any features coming down the pipeline at you from upstream, maybe if you're following it, that you're particularly excited for? Like anything you think, you've talked about the confirmation stuff, which is interesting. Anything you think is going to make this better or anything you think is actually maybe a bad idea or just anything that's like super cool?
Yeah, I mean, I think that the most interesting things in this area that I'm really thinking about is really the mainstreaming of the Gatekeeper project for policy. It's something that we developed a while ago. It runs as an admissions controller. I mean, it's been out for a while, but I think we're starting to see. So for example, there used to be pod security policies as part of Kubernetes. It was sort of a very specialized thing. They actually never got past beta and they're actually on a path to deprecation to be replaced with general purpose policy as implemented by Gatekeeper. And I think that's a really good thing. It's a really good development for Kubernetes in general that people are starting to think like, okay, like, I mean, it's a funny trajectory, right? Because like when we started out, we didn't even have RBAC, right? We had basic authentication, no RBAC. And when we started to add an RBAC, it was sort of like, oh, okay, now we're like in the big league now, right? Like, and by the time you have to, like this is a sign that like people are actually using this thing. And then, fast forward another 4 or 5 years and RBAC is great, but it doesn't tell you anything about the insides of the object, right? It'll say yes or no. It's like a stop sign, yes or no, but it doesn't say like, is the thing you're doing a good idea or not? Right. And so, in the levels of sophistication, the first stage is like, do I know you or not? Do you have my password? The second stage is like, I'm going to give you some fine-grained access control, read and write or delete or whatever. And then I think the third stage is like, I'm actually going to look at what you have in your thing and try and make a judgment call about like, is this actually something that I want to allow you to do? And so I think I'm excited that we're starting to see that mainstream a little bit more. I'm excited that it's being discussed as sort of like a general capability that should be part of what every Kubernetes cluster looks like. I don't think the adoption, I mean, I'm trying to get people to do more adoption. I think it's adopted in a bunch of enterprises, but it's not necessarily being adopted a little bit more broadly. And I think that the reason I'm sort of interested in it is because I'm deeply concerned about some of the software supply chain stuff.
Right.
Right. And I think that like, even today, there's way too much pulling of random stuff off the internet, exposing of ports on the internet. Like, it's very, very scary out there. And along those lines, actually, one of the other interesting things that I've been thinking a lot about lately, it has been sort of sidecar as dependency management, right? So I think that, for a long time, when we think about projects like sidecars, they add capabilities, but I think actually one of the other things they do is they sort of add encapsulation. So you can actually make sort of value judgments that say like, hey, we're going to have a team that focuses on, enablement of clients for something like Redis or Cassandra or whatever, right? And we're going to put that in a sidecar. And in fact, actually, things like the Dapper project that we're working on, right. Take that, do exactly that, and say, actually, the only thing that your developers need to have in there is an HTTP client, and they are not actually going to take a ton of dependencies. They're going to actually mostly keep their dependencies down to a minimum, and we're going to actually try and put the logic and the dependencies in a sidecar where it's a little bit easier for a single team to own it, a single team to reason about it, centralize it. It's kind of like having a library or platform team in a company. But it actually, I think, enables even more sort of encapsulation of stuff like that. That becomes really essential then for being able to understand, like, what is my software supply chain? If software supply chain is encapsulated in hundreds of different images that I run, it's much harder to keep track of than if I can say, like, actually, I'm trying to put it all in this one thing that we share across everywhere. So I don't know. I think that's something I've been noodling on lately.
Okay, presumably with the intention of that becoming first class, right? Because I'm sure people have built tooling to do that kind of thing. It's a new idea to me. It sounds great, but I'm sure somebody out there smarter than me has built that tooling. But I guess, you're looking at getting that first class on the API surface.
Yeah, maybe. Maybe, or just something that you could reason about in policy, maybe via annotations, at least initially.
Right. Okay.
Right. I think there's a lot of opportunity to experiment first. I think before I would want to really experiment a lot before we go too far down. But I do think that we need to start thinking about provenance of images, not just in terms of like, wait, did it come from somewhere that I trust, but actually like, what kind of baggage is it pulling in with it? Right. So I don't know. I think it's very difficult. Like, if you have a cluster right now, it's very difficult to know if there's vulnerable images running in it, for example.
Right? Yeah, for sure.
Yeah, there's no way to walk up to the API server and, other than the image itself, which is okay, but the minute a developer builds that image, you sort of lose track of where it came from.
Right, exactly. And I think, things are meant to be easy, right? So the temptation is definitely to just use an upstream image, to pull it from a public registry, without even maybe, pulling it through sort of a write through cache and a scanner. No, definitely. I've built tooling that tries to address this, but it's identifying dependencies with static analysis of container images, very standard stuff. You're right, making that more first class. I've been on the OPA train. It's really cool to hear about that idea. Using Gatekeeper to do exactly what you said, right? To just lint and say, hey, if you're trying to expose, all ports to 0000/0, like we're gonna deny that.
Yeah.
So making that more sophisticated, and that sounds like a really powerful tool.
Yeah. And I think the other thing I've been sort of thinking about a lot lately is how can you do this in sort of like a warning style too. One of the things I wish we'd built into Kubernetes at the beginning is warnings, right? Like everything that we have now is like yes or no, right? But not sort of like you probably shouldn't, So I think there's more opportunity for that kind of stuff. We have a little bit of that. Like there's a little bit of these kind of warnings coming in now, actually. Into the API surface area.
There's the deprecation stuff, right? If I use extensions, beta deployment, I'm told that I have to stop doing that. But that's the only example I can think of.
I feel like there was something else that I saw recently that Clayton was working on. I can't remember the details, but HTTP does have a warning field, right? Like it has a warning header, like in the spec. Right. There's a header that is dedicated to this. We just have never made use of it, really.
Oh wow. Okay. Yeah, it was interesting when you said that, because I think, you described, auth-n, which is a yes or a no. Do I know who you are? Do your credentials check out? And then auth-z, which is always going to be a binary decision. So I guess you went from no auth to A back to R back. It got more sophisticated, but ultimately it gives that yes or no. That feels like a very infrastructure-y kind of, can this packet flow or can it not? It sounds like you're talking about more of to me sounds like a linter, right? Or more of a dev experience kind of thing than a sort of infrastructure tool.
Yeah. And I think a good example of this is something like resource limits, right? Like you can require that everybody supply resource limits. It's probably not a terrible idea to require that everybody supply resource limits, but you're going to run into a couple of people who are like, no, but my use case is, da, 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 da. And they may be right in that particular case. And so I think it is kind of like that linter at some level where you're like, well, mostly I want this rule to be true and enforced, but like if you're this tall, I'm going to trust that you're sophisticated enough to know what's going to happen if you don't, and I think that's having that ability is valuable and important. And I think so. Another thing. Like the thing of a lot of this in terms of security as well, right? Like, should you block an image that has bash in the container? Right? It's not insecure, right? Bash that doesn't, the newest version of bash doesn't have any CVEs on it. It's a secure binary, but it's probably a bad idea, right? Because nobody really should be, especially with debug containers, which is a cool thing that's been added relatively recently, especially with like debug containers. There's no good reason for anybody to have a shell sitting in their image. And it just makes it easier for someone who breaks out to do stuff.
Yeah.
Right. And it doesn't make it any more secure to remove it or any less secure to have it there at some level, but it does kind of like, I'm into this idea of friction for security. So there's like security as a wall, and then there's security as like the spiky wood things that you put between the walls, right? Where it's like, I'm actually just going to try and make it a little harder for you. I'm not actually going to be able to tell you that it's more secure to a dedicated attacker, but at least I'm going to get more time to find you.
Yeah,
right?
there's always been this sort of quote unquote best practice of containers built on distroless or Scratch, and then host images, a core OS or a COS or an Atomic or something like that. Why do you need a shell? If you need containerd, you need a C library, you need a Go runtime. Like what else are you putting in there? And there's always been ways to address this, static analysis mostly, or just curation by a platform team or an infrastructure team. It's really interesting to me that you're talking about Kubernetes starting to have opinions about this almost, and maybe not leave it up to the operators. Anecdotally.
Well, I would say enable Kubernetes to have the ability to have opinions.
Right.
I'm not ever sure that we would say as a community, we'd say this is the way. I think we would instead say, look, you're going to define the way, but we're going to give you capabilities to do it.
Okay, so this is a bit meta. Right. This is about making that easier and more accessible, and kind of having the opinion that cluster operators should have an opinion, right? Sort of paving the road for them to have an opinion and to not have to use a load of tooling to enforce it.
Yeah, and I think that that's part of it, is that like maybe the right way to say this is there's a big difference between asking someone the question versus expecting them to find the documentation somewhere else, implement it, get it. Like it's just a difference in. I think a good example of this is something like a modern computer. Like a modern computer effectively forces you to turn on password off. Like my iPad, when I reinstall my iPad, and actually I hate it in particular with the family one that all the kids share, like it really tries to force you into having a PIN. And in fact, you have to put a PIN on it and then go into the settings and say, no, I don't want a PIN on it. I trust that, like, I don't put anything secure on this thing, right? Yeah. I think modern computing has sort of said, like, we're no longer going to say, hey, you can figure out how to password encode your thing. We're no longer going to let you figure out how to encrypt it. We're going to actually shove it into your face and force you to turn it off, right? And I think that's actually probably the right thing to do, right?
Yeah. I think that idea with that of a paved road, a set of sensible defaults, and because anecdotally, my approach with developers has always been pretty similar, right? This is what we want you to do. The CI system will fail your build, right? If your deployment.yaml doesn't have a resource request and a limit in it, right? Because they're just good practice. But
in fact, actually, our VS Code work actually puts a red squiggle under your YAML. Right. So we have a VS Code extension for Kubernetes. It puts a little red squiggle under your YAML if you don't put resources in there.
Right. It's I think especially in the days of DevOps when not everybody can be, somebody's maybe primarily a dev and it's not their job to have this kind of expertise. But I think, as you say, my approach has always been if they come to me and say, and argue their case, right, and say, no, I don't want to limit because this is maybe an unbounded job, but all it's doing is some massive, computation, and it's kind of a best effort thing. If we get a result, great. If there's clusters doing other stuff and it wants to kill me, then fine. And if you can make a case for it, that's just an example, but if you can make a case for an exception, then as you say, you add a policy exception or you stick an annotation on, you do, somebody with authority does a privileged operation, and then the cluster sort of lets that kind of thing slide.
Yeah.
Yeah, that's interesting. I mean, I was wondering if do you see the kubelet scanning the host that it's on and refusing to run on a system that's got a shell on it or a Python interpreter or something? I mean, I wonder how far this goes, but
yeah, I don't know. I mean, I do think that kubeadm already starts down this path, right? The way that people install, and certainly like we, as when in AKS, we certainly are seeing increasing demand and desire to pre-configure things for people, right? For the beginning, there was a lot of like, well, but I want to run this and this shell script, and you want to I want to install this thing. And now I think more and more customers are just coming and saying, look, I just want to run containers. Just take care of it all. Like, I don't even want to see the OS at some level. And so I think that's definitely from a provider perspective, that's absolutely where we're headed. And then I think in the community, it's going to head there too, right? Yeah,
I think so. I think a lot of people are building this themselves. I've certainly, I was there when the RBAC, I would say, you've preempted my question, but I was there when RBAC came in, right? And I remember the pain it was. RBAC was absolutely a great addition. It was a great move, but it was a pain to retrofit it, right, to clusters that all of my controllers, especially back in those days, everybody had a hand-rolled Kubernetes install, and suddenly every controller loop needed a service account, and that needed the correct permissions. And I did remember it was a kind of tedious week.
For sure,
it had to be done. So I was going to ask about the migration plan, but it sounds like you're building a sort of opinion of opinions. It's more of an opt-in mechanism. You've preempted a few more of my questions actually about.
Sorry.
No, it's cool. But about where the abstraction level sits and what Kubernetes thinks it is. Is it a platform or a platform of platforms? But we'll get onto that.
Sure.
I about 20 minutes ago, I did want to ask if obviously you're not coding all day on the project now. It sounds like you're still involved at a strategic level, but was there a sense of stepping back, of hanging up you're obviously an engineer and you're a very good one because you worked on this massively successful project, and it's given you, great success, a VP. Was there a sense of hanging up your brackets or whatever the XKCD is?
Yeah, I mean, I think absolutely. I think that's natural. I've never been, and I think it's really explicit from the beginning. We were never intending to build a sort of benevolent dictator for life open source project, right? That sort of, I think a lot of projects ring around a single person oftentimes in these open source communities. I think we were really, really explicit. I don't like those. They're fine, but that's not my notion of a good open source community. So I think we were very explicit from the very beginning to give away power, right? To create SIGs and establish leaders in the SIGs who have pretty exclusive power to generate, and then also have the governance. It took a while to get the governance in place, but get the governance in place so there's elections to the steering committee, and so that people understand how the various things shift. For me personally, I think it's a realization that I'm most happy. Actually, it was the times that in the Kubernetes community that we're most happy were sort of the first 80%. Right. Like I laid down a ton of the early code and I think the last really major, the last major thing that I pushed in was what was called third-party resources at the time, and then became custom resource definitions. And it was a pretty big fight actually at the time, a really big fight. And I came out of it thinking this is just not, it's time to move on. It's time to let the project had gotten big enough that it was time to let a lot of other voices speak. And then also practically speaking, I really enjoy delivering stuff for the customers. and for the end, and for the end users, and being able to build those managed services and have an impact at cloud scale. And that requires sort of building and running and managing a big team, which ultimately takes a lot of time. And so, like, as I said earlier, like the worst thing you can do is sort of keep yourself in the main line when you're a blocker. And so it becomes really important. But at the same time, it was still important for me to stay a little bit involved, at least a little bit. I had that itch that I needed to scratch. So, I found various things, and in a similar way, I wrote the almost of the VS Code extension that we built for Kubernetes, that, it has a bunch of people out there. And then eventually I handed that off when it became clear that like it wasn't an experiment anymore. It has millions of people downloading it, and it needed a more persistent thing there. And I think that's a pattern that persists. I've hung on to the Kubernetes clients because, interestingly, actually, well, first of all, they're relatively low traffic. And then also it's really hard to find people to work on them, actually. Like, oddly enough, like, I don't know why. There's a lot of users. But finding people who want to come work on them has proven to be a challenge. I mean, I found one or two in each one. Like in each client, I found like one or two other people who are passionate and interested and who come and do great work. And so that's
yeah, that's it. I mean, hats off to you. I guess it's there's an award they give out at KubeCon, right? Called the Chop Wood and Carry Water Award.
Yeah, for sure.
I feel like the clients are one of those really high value, really low sexy factor things that, that needs to be done, but you don't get to tackle big algorithms. You don't get to add shiny features in the release notes.
Sure. Yeah. I don't know. It's really interesting. I mean, I find it really interesting for me personally on a couple of different levels. One is because it really gives you a sense for how people are building on top, right? Anybody who's writing code is building on top. They're platform building at some level. They're building an operator, they're building a UI, they're building something. Like if you're not, you're going to use Helm or Kube control or whatever. Like you're not going to be using the programming tools. So you get a real sense for like how people are building, what people are building. And then it's actually really fun. I found personally, it was really fun and gratifying to like implement the same thing over and over and over again in different programming languages. Like it was just a really like interesting exercise in comparing and contrasting. Because I mean, I've used different programming languages in different parts of my career, but generally I haven't like in the span of a day implemented the same feature in multiple places.
Yeah.
And you sort of go, oh, wow, this is interesting. I see it's easy here. It's hard here. It's more complicated. There's some features, that I really discovered that I was like, oh, wow, this is a really good idea. I wish I had this over here. So.
Yeah, it's interesting, isn't it? I was going to talk about it later when we get into the controversial section of the talk about Golang, right, and about the sort of co-evolution of those projects. And Golang is a language with opinions, and it suits certain things. And yeah, if you have the Kubernetes API has a certain structure, has a certain kind of ergonomics to it. Yeah, some languages make it easy to express that. Some languages make it a little bit more difficult. But I guess as
yeah, and I think also the other interesting thing is you find all of the places where things weren't written down. Right. Yeah. So like, there's this general expectation, and I think it's the right expectation that, if kube control works in a particular environment, the client library should work in the same environment, which sort of makes sense. But then you go, oh, wow, like actually there's a whole bunch of stuff that was kind of shoved into client Go that was never documented anywhere.
Yeah.
Right.
There's magic. You keep finding things.
And we do, like literally we just kept finding, I can't remember the specific one, but someone just came in and I think there's some environment variable that it will use to pick up the namespace that you want to be in. That will override like the namespace in the context. Right. And it's used only inside of pods actually.
Right. Wow. Okay.
So like if you're in a pod, the namespace is supplied as an environment variable. It's also, by the way, supplied as a file in the pod. And that is documented.
Yes. Yeah.
But there's an environment variable the client Go looks for. Probably was pushed in before the file existed, some convenience thing. I don't know. But, and no one had ever hit this or complained about the fact that we didn't do this. And then somebody showed up, I think it was in the TypeScript library, and was like, this code doesn't work. And we're like, okay, like we can dig into the client Go, but like, if it's not documented anywhere and it's not a standard somewhere, it's pretty hard for client library authors to you figure out what the right thing to do is. Like, is Client Go the thing that we should just go and emulate? Or is it actually like, is Client Go a specific implementation and there's a general Kubernetes spec for what config loading looks like?
I feel like there's always this, there was a project I was dealing with the other day. Oh, it's Q. I think it was a Q language, right? So there was, there's this lovely statement that says, there's not actually a spec for Q as a language. There's just a reference implementation. Like, that's your spec. But it's imperative, not declarative, right? It's a spec that executes, suspectively understood by machines. And I feel like you always have this, should you have documented all of the arguments and environments and runtime config of kubectl? Should you have documented the APIs? I mean, there's all the proto-driven stuff, right? So actually Kubernetes is fairly, I guess, IDL, API first. But it's interesting. There's always that trade-off between do we sit down, design something up front, document it, and say, right, we have a spec, we have an API. Implementation is, that's it's an implementation detail, literally. It's an exercise for the reader. Or do you deliver code, right? And do you make something work and then try to pick up these pieces 5 years later?
Yeah. And in fact, actually, when we implemented local exec in a pod, when you can do kube control exec and like run something in the pod. The WebSockets implementation of that, including like the error codes and all the numbers for the streams and stuff like that, it's completely undocumented. Like, the only place you can figure it out is by actually going and reading the Go source code that sits in the API server. And then to make matters worse, there's a speedy implementation also, and the speedy implementation is the one, the SPDY is the one that the kube control actually uses.
Oh wow, okay.
So I have this undocumented WebSockets API that most people don't use, but it turns out that actually in most programming languages, it's way easier to do WebSockets than it is to do Speedy.
Yeah.
Because Speedy is deprecated and all this stuff, right? So all the client libraries ended up using WebSockets, and assuming hilarity of like poorly documented and nobody testing it and et cetera, et cetera.
Can't be proxied and don't really spot roles properly and
and then there's that too, right? Of course, like there's also a bunch of these sort of errors that you hit where people are like, I tried to do WebSockets through my HTTP proxy, but it was Nginx, and I didn't know that it was Squid or Nginx or whatever the IT person set up that doesn't handle WebSockets properly. Lots of fun bugs. I mean, but it's good actually. I really think it's important to. I think one of the things that's really valuable about it is it keeps you living the experience of both your customers and the developers on your teams. Right? I think that one of the perils you have as you sort of run bigger and bigger teams is you get abstracted away from kind of like the friction, the stuff that makes their lives unpleasant.
Exactly. Somebody who's looking for a promotion goes and solve that problem for you, and you never even see it.
And so I think it's invaluable to like sit and kind of live the experience of people down and like help be on the front lines of helping somebody with your issue queue and stuff like that.
For sure. No, that does, now you say it like that, it does sound like a really interesting place to be. I'm thinking of the way that Client Go, you can construct a client context in like 1,000 different ways. Presumably each one was just PR'd by one person who had a particular, maybe I'm in a cluster, or maybe I'm in a test rig, or maybe I'm local, and actually maybe my API server is mocked, and maybe I'm not using auth because it's on loopback. And there's a function for that, right? You just call it and you just worked it out. And none of the other client libraries obviously have that because, I guess the Go ones had the most attention. But you can sort of do this archaeology, can't you? Somebody had this requirement one day. I wonder how many other people's production systems now rely on that.
Yeah. Well, actually, so another one that's like that is multi-kube config loading.
I rely on that so much. And
right. So Go client, and actually there's some controversy about whether it was ever a good idea to do it, but it got in and people use it. So, you can have multiple kube configs in the same kube config path. None of the client libraries support it.
Nope.
And it's because, except for Client Go, and it's because it's totally unspec'd. Like the implementation in Go is incredibly long and it's hard to know exactly what it does. And so every once in a while, somebody will pop up and be like, hey, it doesn't work. And we're like, sorry, that's just not happening. Because it's 5% of users and it would be wicked complicated to figure it out. So, and someone else actually showed up recently and was like, why do I have to specify, I'm constructing a config from scratch in the client. Why do I have to specify a context, a user, and a cluster config, right? Why can't I just give you the cluster config and you can just, run through it blindly and there's no auth on my, I don't have a user because there's no auth. I don't want you to do auth. And you're making me specify this user with empty auth basically. And we're like, oh, I guess we could do that. But at what level is it, how hard is it for you to just put in an empty user? So there's all these sort of, little details of people's use cases.
Yeah, I had exactly that. Right? My bash RC builds a kubeconfig colon separated path because that's a thing that's basically undocumented but works really well for my use case. And then I think I use K9S or something. It's written in Python just to work. I guess to bring us slightly back on track, Kubernetes is a sort of mature. I don't want to use the word enterprise grade because it sounds derogatory, but it's a mature, stable project that's trying to address a wide audience. Where do you go? I guess you obviously have a lot of strategic influence from the work you've done in the past and the position you have now. Where does Kubernetes go with this? Is there a big focus on developer ergonomics and trying to bring everybody into the fold and whatever operating system you're on, whatever language you want to use, addressing this particularly to somebody who works at Microsoft, you have a good time with it, or are we kind of saying, well, look, actually only 1% of the people are doing this work and everybody else is realistically going to be interacting with Kubernetes at a completely different level of abstraction. So the people who are doing this, they should just, there's good Go bindings, there's good Python bindings, use one of those libraries, get over it, deliver some value and move on. What is your approach to, it feels like it was a very grassroots, sort of road to success for Kubernetes. It was cool. It was really cool and it was componentized. It ran on Linux. It was very accessible. As a sort of senior engineer at the time, it was like my Friday afternoon R&D project, right? That I sort of spent a bit of time on. And I was like, yeah, this is super cool. And then I showed my boss and it went from there. This wasn't a product that came shrink wrapped and came with Super Bowl adverts. So I correct me if I'm wrong, but I feel like a lot of Kubernetes success came from that grassroots developer first, sophisticated user first. Is that something you all are still concentrating on, or is that now the engine room? And are you thinking just everybody else is just going to have a completely different experience with it?
Well, I guess I would answer it in a different way, which is to say, I think both, I guess. I think it's very, very important. One of the things we did very early on is sort of say what we're not, right? We're not intending to be a PaaS. We're not going to go be Heroku. We're not going to, we draw a line, right? And we're the kernel, if you will. And I do think that a lot of people are going to and should interact with it at a higher level there, right? A lot of people, we are building, we as in Azure have no code solutions now that run on top of Kubernetes, right? We have functions as a service. Many people have built functions as a service that run on top of Kubernetes. And I think that's right. I think that what's valuable is actually that ability to sort of move up and down and interoperate. Right. So it used to be that if you're in a functions as a service environment and you want to do service discovery into something running in a raw container or on a raw VM, good luck. Right.
Yeah.
You're putting it on the public internet and you're dealing with that whole thing. Right. And I think the beauty of being in Kubernetes is that a lot of the primitives are the same. So you may be using a functions as a service, but it's still a container image. So all that vulnerability scanning that you were doing still works the same as if it were a vanilla image. Right. The service discovery, it all works the same. The secrets management, it all works the same. Right. And so I think that, I don't think it's going to be an either or. It's not like people are going to be up in the Heroku layer or they're going to be down in the Kubernetes layer. I think that you're going to see it being more like a traditional operating system where it's sometimes you're going to write something in Bash and sometimes you're going to write something in C and sometimes you're going to write something in Python. Right. And I think that, but they're all going to work together through the same signals and the same threads and the same, infrastructure, right? So I think that's the real value. Even sophisticated developers want to use unsophisticated tools, easy to use tools for certain things, right? And the important thing is the ability to be able to move between them and find the right tool for the right job. So that's sort of, I think, our focus. And I think the great thing about the Kubernetes design is that we can do all that independent iteration on top and other people can do it too. And we can build a really good ecosystem where the tools that are useful to the most people succeed and the other tools fall away. And if we were trying, and this is why we push so hard. We mentioned the custom resources at the beginning. This is why I pushed so hard for custom resources at the beginning, was because it was clear that stuff was going to get built on top of this system. And if everything had to be built into the system, we were going to hit like stasis so fast where we just couldn't make any decisions, right? Where like people are saying, I need this because we were already seeing it with like all the storage providers who wanted to come in and all the network providers who wanted to come in. Like it was horrible, right? And so like getting all these extensibility places in the right places meant you could basically let go and say, okay, ecosystem, go nuts. Let us know when something wins, and we'll start bringing it back into the core.
Yeah, there's been a lot of that, right? This CNI, the CSI, also the work that was done. I think it was Cert Manager, right? The first time somebody said, hey, I want to be an API server too. So can we separate the business logic that's kind of baked in, the first class knowledge of the built-in resources? Can we separate that from the library code that actually serves APIs? I think it was Cert Manager, right, that stuck that crowbar in.
There's a few of those. I mean, that initiative was undergone for a long time. It was very hard to rip it out. And I don't know who the first one to actually use it was. There definitely was a lot of work to isolate the API server code that happened for a long, long time. I mean, that's a good example of engineering that we should have done up front, right? Like if we'd modularized it right up front, we would have done it right. So
I obviously have a question on, is there anything you do differently? But you've kind of touched on something I wanted to talk about. I was going to ask if, you've kind of answered it, but I was going to ask is Kubernetes something that I'm meant, and by that I mean it's API, I guess. Is it something I'm meant to consume? Is the end goal for it ever to be this shrink wrapped product? If I look at the service meshes, right, I look at Istio, Linkerd, it's fairly obvious that one of them wants to be a product that's supported, that's easy to use, that has a nice, clean, ergonomic interface. And one wants to be a platform, right? The Swiss Army knife of tooling that I can build on top of. Was Kubernetes ever sort of consciously aiming for one or another? And maybe, Tim Hocking has talked quite a lot about the kernel distribution model. I mean, do you want to just sort of expand on that a little bit? Like, what's your view on it?
Yeah, I mean, I think that, obviously we wanted it to be usable in the sense that like we were never going to get adoption if it wasn't easy to use, right? But I also think that we never intended it to be a PaaS. Is always intended to be infrastructure. I think we've always thought of it as, and the two concepts that have always sort of rung true for us are that it is application-oriented infrastructure. So instead of previous cloud APIs, which I would say are sort of like physical infrastructure oriented, they were like, it's a machine or it's a disk or it's a network. It's like, it's not an application concept, it's a physical concept. And then the Kubernetes API is really oriented around concepts that you care about as an application developer or maintainer, services and replicas and deployments and things like that.
Ingress.
But it was definitely an infrastructure API, right? It's an IaaS API. It's just a different kind of IaaS API. And then I think also, we always said that it was POSIX, right? And so when you think of POSIX, like it was POSIX for the cloud, like that is the ideal that we were shooting for. And when you think about what POSIX is, like POSIX isn't necessarily, it is intended for end users at some level, but most of the people who interact with it are going to interact with it through higher level constructs, right? And I think that's also a big part of it. So I think both of those things say, like, ultimately we thought probably that people would build on top, and we added a lot of the extensibility because we knew people would build on top. And I think we never wanted to be the whole vertical, because I think if you look at, FaaS, functions as a service, or other kinds of like verticalized PaaS solutions, they have really horrible models where if you hit the limits, you have to eject down to something very, very low level. They don't have this notion of like gradual degradation or even service interconnect, between the complicated bits and the easy bits. And that was clear to us even then, right? We wanted to build for modularity so that, there's a nice, easy stepping stone function downward or upward from infrastructure to platform as a service. I don't think we fully achieved that, frankly. Like, I think there's a lot in the middle between Kubernetes and a FaaS service that like don't exist today. We're trying to build them, but anyway.
But people have definitely built it, right? And then there are distributions. I use that loosely, I guess, that take it further. I'm thinking something like Anthos specifically, which is Kubernetes plus Istio plus a functions, Kubernetes Knative serve, right? All of that stuff. So
yeah, but it's fairly monolithic, I guess, is what I would say. It's not like you wouldn't look at that like it's Java or .NET, where it's like modular in the middle. You can do with it what you want. It doesn't necessarily have opinions, but it's clearly a little bit more abstract than being down in C land. And it's not as abstract maybe as being up in, Node.js or Python or, Visual Basic. Right?
But what do a lot of Python modules do? They, they're just a wrapper, and they actually link against, a C library.
Yeah, exactly. And I think that that's sort of the piece that's in some ways missing in Kubernetes, is that like that linking layer that says like, yeah, there's all this complicated goo underneath you. Here's the easy to use. And there's these individual examples. I think Cert Manager you mentioned is a great individual example of something like that, but it's not a standard library-ish kind of thing. You don't see the pattern.
Yeah. No, right. Brandon, this has been great fun, and I have a whole list of questions I didn't get to that I might just email you or something. But
fantastic. I'm happy to answer them on Twitter. So.
No, this has been super cool. Thank you so much.
Take care, folks. Bye.
Thank you. Bye now.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.